Hello again, everyone. Today we're going to be talking about some special angle relationships. We'll go through the vocabulary first, decide what those definitions are. We'll look at identifying those relationships from diagrams, and then finally we'll go ahead and use those relationships to solve some algebraic equations. So let's look at our vocab first. Complementary angles. Complementary angles are any angles that added together sum to 90 degrees. So angles that sum to 90 degrees. Supplementary angles are angles that sum to 180 degrees. Adjacent angles. Adjacent just means next to, so it's any angles that share a common ray or a side. So angles that share a common ray, and I'll go through what that looks like and then I'll draw you a little diagram. Let's just get that last vocab word in here, which is vertical angles. So vertical angles are always congruent to each other. They're always equal, and they're formed by two lines that intersect each other. So formed by intersecting lines. They're located, I'm going to put opposite from one another, and are always equal. Let's look at a diagram for some of these now, just so we get an idea of what we're looking at. So if we're talking about complementary angles, we said complementary angles have to be angles that sum up to 90 degrees. So we can take a look at, say, a right angle, and then that we see that it's split into multiple parts. We know that it's a right angle because we can see that little box in the corner. So those two angles right there would be considered complementary. Now, they don't have to be right next to each other. We could have an angle, let's say like this, and then we could have an angle that's right next to it, but not sharing a common ray. And as long as they sum to 90 degrees, we can say that they are complementary. So even if I say that this is a 30-degree angle, let's say, even though it's not drawn to scale clearly, and we could call this a 60-degree angle. In here, can't quite fit it. So 30 and 60 together, we know make 90. The first example is an example of complementary angles that are adjacent. The second example I gave you are complementary angles that are not adjacent. Let's look now to supplementary angles. So we can have the same two types of supplementary relationships. We have our first one that we'll show here, where we have two angles that share a common ray. In that case, they would be considered adjacent supplementary angles. Or we can have non-adjacent supplementary angles. So let's say we have an obtuse angle here. Let's say that one's 150 degrees. And let's say we have an angle that's near it that is 30 degrees. If we add those two angles together, again, we get 180. So we can say that they're supplementary. They're just not adjacent. They're not next to each other. All right, if we look down at vertical angles next, we said vertical angles were formed by intersecting lines, and they're located opposite from one another. So I'm just going to draw it up here, even though it doesn't go with adjacent, just because I don't really have the space. But let's draw two lines that intersect one another, right? We agree that this point right here is our point of intersection of the two lines. They are located opposite from one another and are always equal. So let's switch up our colors here so we can see that we have a pair of vertical angles here and here. They make almost a bow tie, if you will. So those are considered an example of adjacent angle, of vertical angles. Wow, definitely not adjacent. They are vertical angles. They are directly opposite from one another. We also have another set. We could talk about this angle up here and this angle down here. Those angles would also be considered an example of vertical angles, and they would always be equal in measure. So let's take a look now at, can you identify those relationships? So go ahead, look at the four diagrams that you see here. One will show you an example of complementary, one will show you supplementary, one's vertical, and one is adjacent. So go ahead, pause the video, see if you can answer these questions, and go ahead and hit start when you are ready. So this might have been a little tricky here because adjacent. Well, we have a couple of angle relationships here that are adjacent. So we see that adjacent could go with this one over here. We can see that, here we go, adjacent could go here. So if you thought about that, you are correct. Adjacent could also go down here. Again, you would be correct. If we're talking about angles 1 and 3, that would also be an example of adjacent. But since I'm only going to be using this one once, I'm going to leave it to the side for now to try to figure out what other relationship we're looking at. It's easy enough to see the vertical one. They're directly opposite from one another from intersecting lines, so I can put that one in its place. It looks like angles that sum to 90 degrees. Over here is going to be our example for supplementary. Complementary is going to be 90 degrees. Supplementary is going to be our angles 1 and 3 over here, which is going to leave adjacent then to going with this diagram. So even though our complementary angle is an adjacent complement and our supplementaries are an adjacent supplement, I could only use the words once. So this is going to be our best answer. So let's scooch down and let's kick it up a notch, because we can. And we'll look at a couple of word problems that talk about these relationships. So if I tell you that the complement of an angle is 81 degrees, what's the measure of that angle? For all these word problems, I love to just sketch a quick little diagram just so that I can see what kind of a relationship, right? I'm a visual person. You guys have heard this before in my videos. So anytime I can draw a diagram, I just think it helps. If we're talking about a complementary relationship, that means that our angles have to sum to 90 degrees. I generally draw my diagram so the angles are adjacent to one another, but that doesn't mean that they have to be. If I'm drawing an 81 degree angle, like that's going to be a pretty significant angle. So 81 degrees is one angle, and then I have this other angle over here. Together, we know they have to sum to 90 degrees. So x plus 81 equals 90. To find the measure of the other angle, I'll subtract 81 from both sides and get that our missing angle is 9 degrees. Okay. So missing angle measure, or the complement of 81 degrees, is 9 degrees. Let's take a look at our next example then. The supplement of an angle is 52 degrees. What is the measure of that angle? So again, let's draw ourselves a little diagram here. If we're talking about supplementary angles, then we know that they are going to create a straight line. So here's our straight line. Again, I choose to draw mine adjacent, but you don't have to. So 52 degrees and then x degrees. So similar to the last one for our algebraic example, we know that angle x plus the 52 degrees is equal to 180 degrees. Again, I can subtract 52 from both sides, and I'm going to be getting 128. So again, I can say that the supplement of 52 degrees is 128 degrees. Right. Last one. So this one, again, we need to look at the student work that's here and then be able to find and correct the error. So take a minute, look at the diagram, try to look at what relationship you see, look at the work that's there. Go ahead, pause the video, try to figure out what relationship do you see in that diagram, and then what problem do you see in that student work. Well, from this diagram, we see intersecting lines and we see angles opposite from one another, which means we have a vertical relationship. And vertical angles are always going to be equal to one another. So it appears in the student work here, the person might have thought that they were supplementary angles because they set them equal to 180 degrees. But if we're going to set this up correctly, we know that 5x has to equal 100 degrees. If I solve